Now let us look at a few signs. See here, this is a case of gross pneumoperitoneum, a supine abdomen radiograph. There are a few signs which are seen. Let us look at them one by one. The first sign is what is called as football sign. Now watch very carefully here. In the abdomen, can you see a round lucency like this? More or less over the central abdomen. Can you see this round black appearance or lucent appearance? Now what happens is when the patient is supine, remember that air in the body always has a property. It always tries to ascend up to the most non-dependent part. So what happens in the supine position, where will all the air go? The air will rise up, and then the air will collect just underneath the anterior abdominal wall, right, just under the dome of the anterior abdominal wall in the central area. So this is what gives rise to this oval kind of a round appearing lucency. This is what is called as the football sign of pneumoperitoneum. Yes. Now the next sign is what is called as cupola sign. Now do you remember in pneumomediastinum, right, in respiratory system, we have discussed that when free air lines the dome of diaphragm from above, right, it creates a sign which is called as the continuous diaphragm sign. What happens in pneumoperitoneum? Now there's free air in the peritoneal cavity. This goes and lines the dome central tendon of diaphragm from below. Now when the diaphragm is lined by air from below the central tendon of diaphragm, you see a more or less sharp margin of the inferior, sharp margin along the inferior surface of the diaphragm like this, and this is what is called as the cupola sign of pneumoperitoneum. Correct. Now another very interesting sign is what is called as the falciform ligament sign. Can you see this small vertical line here on the surface, anterior surface of liver here? This is called as the falciform ligament sign. Now what is the falciform ligament sign? Now see, a falciform ligament is a bilayer fold of peritoneum which is there on the anterior surface of liver. Now can we usually see the falciform ligament on an X-ray abdomen? The answer is no. Why? Because the falciform ligament is say a fold of peritoneum, so it is a membrane. So what is its density on an X-ray? Its density is water density. What is the normal content of peritoneal cavity? It is also fluid, water density. So both of them are of the same density. I will not see a sharp margin between them, right? So this is differential radiographic density theory, correct? So for seeing a sharp margin, I need two densities, because the membrane is also water density, fluid is also water density. I will not see the falciform ligament on an X-ray abdomen erect, right, or X-ray abdomen in the supine position as well. But what happens in pneumoperitoneum now? The peritoneal fluid, it is replaced by air. So now this free air in the peritoneal cavity, it will come and line the falciform ligament on either sides. Differential radiographic density theory will create a sharp margin. This is what is called as the falciform ligament sign when it becomes visible on an X-ray of the supine abdomen in pneumoperitoneum. This is falciform ligament sign. Another interesting sign is what is called as the liver edge sign or GB surface sign. Now again the concept is same, right? We are not able to see a sharp margin of the liver on an X-ray abdomen for the same reason that we just discussed with falciform ligament. We are not able to see the outer surface of the gallbladder or the serosal surface of gallbladder. But what happens in pneumoperitoneum? When there is free air in the peritoneal cavity, this free air comes and lines the inferior edge of the liver. Differential radiographic density theory creates a sharp margin. We are able to see the sharp margin. Similarly, free air comes and lines the serosal surface of the gallbladder. Differential radiographic density theory creates a sharp margin. We are able to see it as a sharp margin. These are called as liver edge signs or gallbladder signs. Right. Now another very beautiful sign is called as Rigler's double wall sign. Now just pay attention here. Whenever you see a bowel loop, right, you see a bowel wall margin like this. Now what is this margin or surface that you see? Tell me. Is it the mucosal surface or is it the serosal surface? Let me give you a clue. Now the bowel wall, remember, is a soft tissue structure. So what is the density of the bowel wall on an X-ray? The density of the bowel wall on an X-ray is water density. What is the normal content of the peritoneal cavity? It is fluid, water density, right? So can you ever see the serosal surface as a sharp margin? No, because the bowel wall is also water density. Outside it in the peritoneal cavity, you have fluid which is also water density. So you cannot see the outer wall or the serosal surface of the bowel. Can you see the mucosal surface? Yes, in situations where the bowel lumen is going to contain air, If it is distended with air, now the bowel lumen is going to contain air. Now the mucosal surface is bowel wall, which is water density. This creates a differential radiographic density theory, right? And therefore this creates a sharp margin, right? And we can see a bowel wall margin, which is always the mucosal surface or margin, right? So we normally, when you look at a radiograph of intestinal obstruction, right, you see a bowel wall margin. Remember, therefore it is always the mucosal surface, it is never the serosal surface. Now just think what will happen in pneumoperitoneum. In pneumoperitoneum, what will happen is that the peritoneal fluid is going to be replaced by air. So this air will now come and line the serosal surface. Now bowel wall is water density, outside it there is air density. Will I be able to see the outer serosal surface as well? Yes. So the appearance changes. What happens is I am able to see the inner surface as well as the outer surface, right? Mucosal as well as serosal surface. This is called as Rigler's double wall sign. So if you watch carefully here, look at these bowel loops here. You can see a sharp inner surface on this side. You can also see a sharp outer surface or serosal surface. Look at this bowel loop here. You can see the mucosal surface on the inner side. You can also see the serosal surface as a sharp margin. When you see both mucosal as well as serosal surface at the same time, right, this is what is called as Rigler's double wall sign. Another classical sign is what is called as Doge's cap sign. Now Doge's cap sign is nothing but the air which is trapped in the Morrison's pouch. What is Morrison's pouch? Remember, Morrison's pouch in the supine position is one of the most dependent parts of the peritoneal cavity. It is called as the hepatorenal pouch. So this space posteriorly here, right, between the liver and the kidney is called as Morrison's pouch. Now if the patient is lying supine like this, right, if this is the abdomen, this is going to be the liver like this, this is going to be the kidney. Here this space posteriorly is called as the Morrison's pouch. Now remember, air always has a tendency to rise up, and that is the reason why we get this football sign when the air rises up just below the anterior surface or just below the anterior abdominal wall, correct? But sometimes air goes and gets trapped in the dependent part here. Air usually rises to the non-dependent part. Sometimes, however, it gets trapped in the dependent part in the Morrison's pouch. When it gets trapped there, it creates a more or less triangular appearance, an eccentric triangular appearance like this. This is what is called as the Doge's cap sign. So if you see here, this triangular lucency that we are able to see here, is actually trapped air which is there in the Morrison's pouch. This creates a triangular lucency, triangular shaped black appearance or triangular lucency like this. This is what is called as the Doge's cap sign. So these are various peculiar signs that we can see on X-ray supine abdomen, on pneumoperitoneum.